Problem number 1 asks you to write a polynomial that is the third degree and has zeros that are at 3, -2, and 4. We need to write it in factored form and standard form. So, given the zeros, we're going to start in factored form. So, let's just say you had a factor x plus 5. I would ask you, okay, well, what is a 0? X equals what? You set that equal to 0, subtract 5, so you're going to say x is -5. So, if we take that concept and apply it and do the opposite, then if I give you that the solution, x equals 3 for our first 0, then what is the factor? So that would be x minus 3. So if I had a factor or a solution of -2, then my factor had to have been x plus 2. And the last one for 4 is x minus 4. So this is the polynomial in factored form. And just like we did before when we graphed, if you count up all the x's, then you have 3, so it's a third degree. Now, when we write it in standard form, we're simply going to just distribute. So I'm going to start with distributing the first two binomials first. And when I do that, I get x squared minus 3x plus 2x minus 6. I'm going to combine like terms in the middle, and I'm left with x squared minus x minus 6. And then my last step is to bring down this binomial here and multiply my trinomial that I just got by x minus 4. So we multiply by multiplying everything on the left to everything on the right. And when we do that, we get x to the third minus 4x squared minus x squared plus 4x minus 6x plus 24. Again, we can add like terms in our quadratic and our linear terms. So the final answer in standard form is x to the third minus 5x squared minus 2x plus 24. And again, if you were to look at this, it follows the criteria of having to be a third degree. In number 2, it's still a third degree polynomial, but we have zeros at 0 and at -3. But then we have to note that at -3, we have multiplicity of 2. So in factored form, we would have y equals. Okay, so for a 0 of 0, technically in the factored form of that is going to be x plus or minus, it doesn't matter, 0, right? Well, that's just x. So we're just going to have x out in front. And remember, this is the factor, whether we're writing it in factored form or whether I'm asking for the 0 given factored form, that we always forget about, okay? Because it's not plus or minus anything. So what makes x 0? 0. All right, so then with a factor or a solution of -3, our factor is going to be x plus 3. And it's not a third degree polynomial until we add our multiplicity of 2, so it would look like this. So this is the factored form of our polynomial. Now, the first thing we have to do is we have to square this x plus 3 binomial first. And if you must, then you're going to write it twice and you're going to multiply because we always forget that middle term. So when you do that, and again the x just tags along, you're going to get x squared plus 6x plus 9. So then the last step then is to just distribute an x. So in standard form we get x cubed, which is what we needed, plus 6x squared plus 9x. And that's our polynomial in standard form. In number 3, we have zeros at 3 and 2i and -2i. So remember what we've talked about before. Imaginary numbers come in pairs because you always have I root something. And whenever you have a root, a radical symbol, you have to have plus or minus. So the fact that we have 2i and -2i is exactly what we need and makes total sense because they come in pairs. So the same value, but one's positive, one's negative. So we're going to apply the same concept as we were doing before, but we just have two imaginary roots. So in factor form, we have y equals x minus 3. And then it's the same concept, except instead of x minus 2, we have x minus 2i. And instead of x plus 2, we have x plus 2i. Now, whenever you have an imaginary number, when I'm asking you to write it in standard form, you're going to want to distribute the imaginary two parts first. It just kind of, you'll notice things start to cancel and it just makes it a lot nicer. So always start there. So when you do that, you get x squared, and then you get plus 2xi minus 2xi. And again, it doesn't matter if you write xi or ix, it's the same thing. And then we have minus 4i squared. Well, immediately these two cancel. And then you need to remember that I squared equals negative 1. So this turns our binomial into x squared. Instead of minus 4, now we have plus 4. And then the last part is just to bring down that x minus 3. And now we're going to multiply that linear binomial by our new quadratic binomial. And when we do that, we get x to the third minus 3x squared plus 4x minus 12. And that's our equation, our polynomial in standard form. Okay, so try number 4 on your own and then see if you get exactly what I get. So pause the video and then try it and then hit play and then I'll explain it. Okay, so the beginning of this is the same as it's been. We have x minus 3. And now we have 4i, just like we had 2i, so you probably got x minus 4i. However, I said before, imaginary roots come in pairs. So they come in pairs. So that means that if we have 4i, we also know that we have negative 4i. Okay, so that's that property coming into play. Okay, so I have x plus 4i. And again, we're going to start by multiplying the two imaginary parts first, which gives me x squared. And then I get positive 4xi and negative 4xi, so those cancel. And then I'm left with minus 16i squared. Since I squared is negative 1, then we get x squared plus 16. And then our final part is to multiply it by this linear binomial in front. So our final answer in standard form is x cubed minus 3x squared plus 16x minus 48. So this worksheet was just to get your brain thinking a little bit, using the properties that we know and we know how to multiply, we know how to factor, we know how to write our zeros and all those things. So it just kind of gives you a viewpoint. You know, we've been given polynomials in factored form and in standard form, but the question is that if I give you a graph, can you create one? And you have all the tools and knowledge to do so.